Hello, kiddos. I hope everyone is having a great week at school. So today we're going to talk about the powers of 10. So if you look at this chart here, when you see 10 with a little 1 up here, you would say this 10 to the first power. That simply means 10 one time, right? The second one is 10 squared. You can say 10 squared when you see a 2, or you can say 10 to the power of 2 or 10 to the second power. That just means 10 times 10. And as you look down the chart, hopefully you're going to see some patterns as we talk today. So before we start talking about powers of 10, we need to look at some vocabulary words. So 3 vocabulary terms that may be new to you is exponential expression, exponents, and base. An exponential expression is made of 2 parts. So right here, this is an exponential expression. The big number is called the base raised to an exponent. The little number is always called the exponent. Okay? The whole thing, anytime you have a number or a variable raised to an exponent, that is called an exponential expression. The exponent indicates the number of times the base number is multiplied by itself. So basically, we're talking about repeated multiplication. You might say the exponent has the power of multiplication. Powers of 10, so exponents can also be called powers. Powers of 10 are any numbers that can be reached by multiplying 10 times itself. They can all be written as the base number 10 with an exponent of whatever number, how many times it's being multiplied by itself. So here we have 10 to the second power, or 10 squared. This one we would say 10 to the fifth power, or we could say 10 to the power of 5. And that simply means 10 times 10 times 10 times 10 times 10, a total of 5 times. When you see a 10 with an exponent, you read it like this: 10 to the whatever it is, fourth power. So this one, 10 to the fourth power, or like I said earlier, you could say 10 to the power of 4. And then the little 2 has a special name. You could say squared, and even the number 3. If you have an exponent of 3, you could say cubed. Cubed. Numbers, especially very large and very small numbers, can be represented with powers of 10. When you think about it, exponents are just a shorter way to write a multiplication expression. The base number tells you what to multiply, and the exponent tells you how many times that number appears in the expression. For example, we have this great big number here. This great big number can be written in short form called 10 to the 12th power. Now, what do you notice about how many zeros are up here? You guys count those. So do you notice there's 12 zeros? So hopefully you're going to see that pattern repeats over and over. All right, so here are some examples of exponential equations using the power of 10. 10 raised to the power of 2, or 10 squared. You write 10 times 10. 10 cubed, the 3, you can say cubed, or 10 to the third power, or 10 to the power of 3. All of those are appropriate to say. 10 times 10 times 10. And then notice the other ones. This one we would say 10 to the fourth power, 10 to the fifth power, and 10 to the sixth power. How are you feeling? Does that make sense? I hope so. All right, so you guys try. How would you write the exponential expression as repeated multiplication? How do you write 10 to the fourth as repeated multiplication? I bet you guys already know it. It's 10 times 10 times 10 times 10. You got it, dude. Or what about this one? How would you write this exponential expression as repeated multiplication? How do you say this, you guys? 10 to the seventh power, or 10 raised to the power of 7. Both of those are appropriate. Multiply 10 together 7 times. How would you write this exponential expression as repeated multiplication? Did we already have that one? We did. This is a repeat. So I bet you already got it right. All right, what about these? It says solve these exponential expressions. What is their value? If you multiplied 10 by 10, what would you get? What if you multiplied 10 together 3 times? What's 10 times 10 times 10? So on and so forth. Well, let's look at the answers. 10 squared, or 10 to the second power, is 100. 10 cubed, or 10 to the third power, is 1,000. 10 to the fourth, I'm sorry, did I say 10,000? I meant to say 1,000. 10 to the fourth is 10,000. 10 to the fifth is 100,000. And 10 to the sixth power is 1,000,000. Do you notice anything? Hopefully you do notice that the number of zeros in the answer is the same as the exponent. So 10 to the third power, the answer has 3 zeros. 10 to the sixth power, the answer has 6 zeros. And every time we're talking about raising 10 to a power, that pattern will always be true. So what would 10 to the 10th power have? How many zeros would that number have? It'd have 10 zeros. That would be a huge number. All right, now that you understand the powers of 10, we need to look at what happens when you multiply or divide a whole number or a decimal by a power of 10. Let's start with multiplying whole numbers. If I have 14 times 10 squared, we end up having 2 zeros in our answer. 14 followed by 2 zeros. Here I have 14 times 10 cubed, which is 14 followed by 3 zeros. 14 times 10 to the fourth, 140,000. That has 4 zeros. So on and so forth. All right, I bet you see the pattern again. Yes, the number of zeros added matches the exponent, but it's important you understand what's actually happening because that only works for multiplying whole numbers. This pattern, the number of zeros matches the exponent, only happens when you're multiplying whole numbers. So it says we could multiply these out and get our answers, but there's a quicker way when multiplying by powers of 10. What is the quicker way? What is actually happening when we multiply by a power of 10 is that the decimal is moving to the right. The number of times it moves is based on the exponent. So if you have a whole number, that means the decimal is sitting to the right of the last digit, right? So if the decimal were right there, this number tells us how many times we're going to move that decimal to the right. So 14, we would move it 1, 2. It's after the 14, we'd move it 1, 2. We're going to move our decimal 2 places to the right, which is where we would get our 2 zeros from. So 14 times 10 to the third power is 14. Move our decimal 1, 2, 3 places, and we would put decimal at the end. That means we'd have to add 3 zeros. So the answer would be 14,000. So let's look at multiplying by powers of 10, multiplying decimals by powers of 10. Well, same thing. We're going to move that decimal to the right, however many places this number is. So if we move our decimal to the right 2 places, we would go 1, 2. So the decimal would be between the 2 and the 3. So 1.423 times 10 squared is 142 3/10. This one, we're moving our decimal all the way to the end, 3 places. So this times 10 to the third is 1,423. And you can see the last example as well. The decimal is moving to the right the same number of times as the exponent. Now you guys try. So you guys write down the answers to these 5 problems. Hopefully you paused the video and you did that on your own. And now we're going to check your answers. All right, 18 times 10 squared is 1,800. 1.8 times 10 squared is 180. 12.367 times 10 to the fourth is 123. I'm sorry, 123,670. 465 times 10 cubed is 465,000. And 0.982 times 10 to the 6 is 982,000. I know you guys got all those right. All right, so what do you think is going to happen if we divide by powers of 10? What do you think would happen? Well, if multiplying moves our decimal to the right, it would make sense that dividing moves our decimals to the left. So 148, if we added a decimal, it would be behind the 10. Since we're dividing, we're going to move our decimal to the left one place. So the decimal would move up and be between the 4 and the 8. On the second problem, we're moving our decimal to the left 2 places. On the third one, we're bringing our decimal to the left 3 places. And on the fourth one, you can see what happens. The decimal is moving to the left the same number of times as the exponent. It works the same way with dividing decimals by powers of 10. The decimal is moving to the left the same number of times as the exponent. Now you guys try. All right, here's 5 problems. I want you guys to write down the answers. Pause the video and do that, and then turn the video back on and check your answers. All right, are you guys finished? Let's see what you get. So the first problem, the answer is 1800ths. The second problem, we have 0.018. The third one, 0.01237. The next one, 0.0046. And the last one is 12 and 502 thousandths. All right, guys, so that's your entire slide deck for today. You do have a quiz for Thursday, and if you have any questions or you need any help on it, let me know. You guys have a great day, and I will check in with you later.